Hello, and welcome to the lecture on solving equations. So the objective today is to define algebra, name some uses for algebra, recognize when an algebraic statement. So we'll talk about term, expression, equation. We did talk about this briefly at the beginning of the first unit, so this will probably be a bit of a review for us. And then learning how to solve for an unknown variable in a simple algebraic equation. So firstly, we've talked about this before. So a variable is just a letter or a symbol that represents a number, and we can use any letter in the alphabet. So you would have seen this in the beginning of the Algebra 1 unit. We used a lot of different letters. So it doesn't have to be just the letter X, it can be any letter of the alphabet. I think we also talked about this as well. So an algebraic expression is a group of numbers. So it's just the exact same thing, but we don't have that equal sign. And then for the algebraic expression, we can have one or more algebraic terms. And again, it just doesn't include the equal sign. When we have an algebraic expression, we can similarly find a value. So this just means that we can sub in, and we talked about this in the substitution unit previously, we can sub in any value to evaluate this algebraic expression. So if we let m equal 2, then we'd get 2 plus 8 equals 10. And in this equation, if we let r equal 5, then 5 take away 3 would be 2. So similar to our substitution. So an algebraic equation is the exact same thing, except it has an equal sign in between. So it's a mathematical sentence stating that two expressions are equal. So in other words, that the left-hand side is equal to the right-hand side. So in this equation, we have 4 plus 5 equals 9, which is true because 5 plus 4 is 9. So on this one, we have a different algebraic equation. Now in this one, it's hard to see. It would depend on, so this is more of a formula that we would typically use. It depends on what we're solving for. And then in this equation, we have x plus 3 equals 15. So the question is, what would I sub in for x to make it equal to 15? So the answer would be 12, right? But we're going to learn how to do this without just guessing or estimating. We're going to learn how to actually solve using algebra. So we also talked about this before, but just to review, the number in front of your letter is your numerical coefficient, so this is in front, and then your variables are any of the letters attached to it. Our numerical coefficient also includes the negative sign if there's a negative sign in front. We can also sometimes talk about the symbol pi. That's also a constant because it's always the same value. So pi is an infinite decimal, but it is in fact always the same value. Whereas the variables can be, anything that we let it be. They hold the place of a number. The biggest thing to remember when we're solving an algebraic equation, we're trying to find the whatever x or whatever letter, the variable, is we want to get the unknown alone on one side of the equation. It does not matter if it's the left side of the equation or the right side of the equation, but we need to make sure that the variable is alone on one side. You can get the unknown alone by using mathematical operations. So we'll talk about this and we'll see lots of examples today. But again, the goal is to get the unknown by itself. So the biggest thing to remember is whatever math operation we do to get rid of something on one side, we must do the exact same operation on the other side to keep our equation balanced. So we always say whatever you do to one side, you have to do to the other. And I'll probably repeat this multiple times throughout this video, but that's the biggest thing to remember is whatever we do to one side, we have to do to the other. Otherwise, if we don't, then we risk the integrity of the equation, or in other words, it's not going to be balanced anymore. Okay, solve using addition and subtraction. So the first thing we're going to look at is solving for, we're just going to keep it simple with x, but we're going to solve for this variable using addition and subtraction. So firstly, why are we using addition and subtraction? So the first thing I want to talk about is that the opposite of addition is subtraction. So to undo addition, we have to subtract, and to undo subtraction, we have to add. So these are opposites. And the same is true for multiplication and division. Those are opposites of one another. To undo multiplication, we divide, and to undo division, we multiply. So we have to keep this in mind. So the first thing we always do is we check to see what operation is happening to our variable. Oops. So in this equation, we have x plus 6 equals 5. So our x, we're going to ask, so we know where our x is, we're going to ask ourselves, what is happening? Okay, so there's a 6 here. The question is, is the 6 being subtracted from x? Is it being added, multiplied, or divided? Well, we can see the plus sign in between, so we can say that this 6 is being added to the x. So we can see the 6 is being added to the x. So because it's being added to the x, then we need to do the opposite. So the opposite of addition is subtraction. So we need to subtract 6 to get rid of it. So what does this look like? So we're going to do it the long way first. So we have x plus 6 minus 6, right? So we're going to subtract 6, and the reason we do that is because anything, so a plus 6 minus 6 will become a 0, right? Which is the whole point. We want to get that 6 away from the x. Our goal is to get x equals something or something equals x. So like I said, the x can be on the left-hand side or the right-hand side. It doesn't matter. On this equation, the x is already on the left-hand side, so we're just going to keep it there. We're going to move the number away. So because we subtracted 6 from the left-hand side, whatever I do to one side, I always have to do to the other. So because I subtracted 6 on the left-hand side, we also need to subtract 6 from both sides. So this is super important, and this is a step that students typically forget. So when I subtract 6, this becomes a 0, right? We're not going to write the 0, but just so you can see. And then in our calculator, if we can't do it in our head, we do 5 take away 6, and that'll give us a -1. So we're going to get rid of that 0 because anything plus 0 is, or minus 0 is just itself. And you don't have to write that middle step, but just so you can see what's happening here. So we get x equals -1, and we're done. Because we have nothing attached to the x, there's no number in front of it or being added to it or being divided, and we have x equals -1. So that would be our solution. And we can always check our answers. You don't need to do this, but in order to check our answer, our original equation was this. So I said that x was equal to -1. So I'm going to check and see if this is true. So wherever I see an x, so this goes back to our substitution that we just learned. So wherever I see an x, I'm going to put a -1 in. And then I'm going to go to my calculator. I'm going to go -1 plus 6. That'll give me a 5. And if my left-hand side equals my right-hand side, I'm happy, which it does. So we did find the proper solution. So we could check our answers as well. Definitely don't have to, but we can. Okay, so let's move on to the next one. So now we have x plus 2 equals 5. So we will look at what's happening. So this is my original equation. Just going to write it out here. So what's happening here? And normally if I had students, I would ask. So what's happening here is that 2 is being added. So we look at what's happening to the x. There's a 5 on the other side, but we're not worried about that. We're worried about this 2 beside the x. So 2 is being added to x. So because it's being added, I'm going to subtract 2 from both sides. I'm just going to use BS for both sides. So we're going to subtract 2 from both sides. So what does this look like? So we have x plus 2, take away 2, equals 5, and we're going to take away 2. So we took away 2 from this side, and we took away 2 from this side. When we do that, this becomes a 0, right? So we're not going to write that. But we're going to figure out, so the left-hand side is just an x now, and on the right-hand side, we have 5 take away 2. That's going to give us 3. So the answer is x equals 3. Sometimes students don't like to write this middle step here just because it sometimes can get a little bit confusing. So you can also think of it this way, and you're doing the same thing, but some students like to just say, okay, there's a plus 2, so to get rid of it, I'm going to do a -2 here and a -2 here, and I'm just going to write it up top. I know that when I do that, my x is now by itself, And then in my calculator, I go 5, take away 2, and that gives me a 3. So both will get you the same answer. It just depends what works best for you when you write it on paper and what makes most sense in your head. So let's do another check of our answer just to see. So our original equation is x plus 2 equals 5. We said that x is equal to 3, so we're going to put a 3 in wherever we see an x. Oops, not a 6, a 5. Can't even see my own writing. So then we get 3 plus 2 gives me 5. So we get 5 equals 5, and we're happy because left-hand side equals right-hand side. Okay, so now we have an equation that looks a little bit different. So first off, I can see that my x is on the right-hand side of the equation, of the equal sign, and I have a 4 being subtracted this time. So it doesn't, this is just to see that it doesn't matter if your x is on the left-hand side or right-hand side, we follow the same process. So we're still going to look at x and what is happening to x. So 4 is being subtracted. From x. And the same thing applies. So opposite of subtraction is addition. So we're going to add 4 to both sides. So what this is going to look like, I'm going to add a 4 to the left side, and I would have had to add a 4 to this side. Again, you don't have to write this step, but just at the beginning we like to, so the students know what we're saying. So this goes away, right? That becomes a 0. So we get 8 plus 4 equals x is all we're left with. So we get 12 is equal to x. And we can check our answer using the same method, but we're not going to do that. But just notice here that I have a number equal to x instead of x equals 12. But these are this, we're saying the same thing here. You don't have to rewrite it as x equals 12, but just remember that it doesn't matter if it's on the left-hand side or the right-hand side, as long as we have x by itself. So for this one, x plus 2 equals 0. So we know that a 2 is being added to this side, so we're going to subtract 2. And on the other side, we're also going to subtract 2. So the reason I put this one in here is sometimes students think that 0 take away something is just 0, but that's multiplication, right? 0 times anything is 0, but if we're subtracting 2, you could do this in your calculator, or you could just know that 0 take away 2, we have nothing, and then we're taking away 2. So we end up with x equals negative 2 as our final answer. And we can check that. Negative 2 plus 2, and that's going to give us 0 equals 0, and we're done. Okay, so now using multiplication. So to solve an equation, such as x plus 9 equals 13, this is the one we just did, we subtracted 9, right? We'd subtract 9 from this side and subtract 9 from this side, because the inverse or the opposite of addition is subtraction. In other words, subtraction will undo addition and vice versa. So in the same way, multiplication and division are inverse operations. So addition and subtraction are opposite, and multiplication and division are opposite. So these operations undo one another. Subtraction won't undo multiplication, addition won't undo division. These have to go together. They're the opposites of one another. So the steps are the exact same. We're trying to find the unknown, so in some cases x. So we're trying to find the unknown, and we need to get it alone on one side of the equation, and we can do this using multiplication or division as well. It just depends what's happening to x. So, and then we always have to remember whatever we do to one side, we also have to do to the other side. Okay, so let's start with division. And you won't be told that you have to solve using division. This is just for teaching purposes. But if I didn't know what was being asked of me or what I'd have to do to get the x by itself, we're just looking, what is happening to this x? There's a 15 on the right side, but this isn't doing anything to my x. What I'm worried about is this 5 attached to my x. And the question is the x being added to the 5 or subtracted, multiplied, or divided, right? So we know when things are just touching like this, there's no addition, no subtraction in the middle. Sometimes there's brackets around, but in this case, there's not. But because they're side by side, we can say that 5 is being multiplied by x. So multiplied by x. And I know that the opposite of multiplication is division, so I'm going to divide by 5 on both sides. So what does this look like? I'm going to rewrite it here. It means that, I'm going to switch to a different color here. We're going to divide by 5 on this side and divide by 5 on this side. So we have to do it to both sides. So remember, that is a really important thing to just keep in mind. So when I do that, this 5 divided by 5 goes away. That's the reason we did it. If it doesn't go away and there's still a number in front of the x, we did something wrong. So 5, anything divided by itself is 1, right? So we could write a 1x is equal to, and 15 divided by 5 is going to give me 3. And again, you can use your calculator for this if you wish. Now, we know mathematicians are lazy. If this was a -1 in front of the x, then we don't have x by itself. When there's just a 1, though, in front of the x, we're done. So x equals 3 is going to be our final answer. And we can check our answer by going 5 times 3, and then we get 15 equals 15, and we're happy. Our left-hand side equals our right-hand side. Okay, so let's do the next one. So we have 330 is equal to -15x. So our x is on the right-hand side, but that's okay. Not going to panic, but we're asking ourselves what's happening. -15, so we also need to include the sign with that number, okay? Because if we don't, we risk being left with that negative attached to the x, and we don't want to do that. So we're going to take the entire -15, and it's being multiplied by x. So I'm going to divide by -15 on both sides. So we're going to divide by -15 on both sides. So I'm going to divide by 15, pardon me, -15 here, and divide by -15 there. Switch back. Okay, and then this goes away, right? It becomes a 1. That's the whole reason we did it, was to get rid of it because it was attached to my x and I don't want that. And then in my calculator, I can, sorry, I can take 330 and divide it by -15. So make sure you're using -15. So that's going to give me -22, sorry, is equal to x. So because there's nothing else happening to my x is all by itself, which is what I wanted, I'm done. And let's check our answer. So we have 330, we're going to go -15 times -22. So in our calculator, we're going to go 22 times, or sorry, -22 times -15. That will give you that positive that you need. So we're going to get positive 330 is equal to positive 330, and we're done and we're happy. So again, just looking at what's happening to x. So in the first one, there was a 5 being multiplied, and the second one, a -15 was being multiplied. And to undo it, we do the opposite operation using the exact same number. So some students get confused about that, but we're going to use the exact same number because when we do that, it becomes a 1, and our x is by itself. Okay, the pesky -1. So I call it the pesky -1 because often it gets missed. And we can't have this. So I did talk about it briefly in the last couple examples. When I have a negative x, I don't have my x equals what I want or what I want equals x, right? Because that negative in front is not the same as just a 1. We can't have a negative in front of our x because it's not by itself. So there's a couple ways you can think about it, but we're going to think about it the same way we've been thinking about the previous questions. And that's that, remember, there's a 1 there. Mathematicians are lazy, we don't write the 1, but there's a -1 there. So x is being multiplied by -1. So in order to get rid of this, we're going to divide both sides by -1. So we're going to divide this side by -1 and this side by -1. That cancels that -1 out, which is what I wanted. And then I get x is equal to, so 11 divided by -1 is going to give you -11. And again, you can check that in your calculator if that's not something that comes quickly to your brain. That's totally fine. We can use our calculators as much as we want at this point. So we get x equals -11 as our answer. And we're happy because our x is by itself. Now, in the next one, we have -16 equals -x. So my x is on my right-hand side, but I'm not going to panic. And I do see that there's a negative, and I'm going to write that 1 in there just so my brain knows what to do. But there's that -1 in front of the x. So let's get rid of it. And to do that, we're going to divide this side by -1. And whatever I do to one side, I have to do to the other. That gets rid of my -1, which is what I wanted. And then I'm going to go to my calculator if I can't remember the rules of negatives, and I'm going to go -16 divided by -1 using that plus minus key. And that'll give me a 16 is equal to x. So you can notice here, rather than, if you want to do it the long way in and divide by -1, you can. But essentially all this negative in front does is it means we flip the sign of the other value. So we had a positive 11 and you can see it flipped to a negative, right? And we had a -16 and it flipped to a positive. So you can just think of it as flipping the signs, but if that doesn't really sort of stick with you, the reason it happens is because we're essentially dividing by -1. So hopefully that makes sense. Okay, so now we have division, but we're going to use multiplication to solve for it. So it's kind of confusing because I just called the last one division. Okay, so again, we're looking at our x, or our variable. In this case, I've continued to use x because I find it less confusing for students. So we have this x on the top, and we're going to ask ourselves, what is happening to it? Well, there's a 2 on the bottom here, and I know when I have something laid out like this, so this line here indicates division. So it tells us that x is being divided by 2, and the opposite of division is multiplication. So we're going to multiply by 2 on both sides, BS on both sides. So this this one gets a little bit, not tricky, it's certainly not tricky, but I'm just going to write it out like this, just in a different color. So we're multiplying both sides by 2. So this looks like a little bit messy sometimes because we have this fraction, this x over 2. So when I multiply by that number, a 2 divided by 2, so 2 over 2, they cancel out, or in other words, they divide out, and this becomes a 1, which is why we did it, right? So if we don't get a 1 at this point, or we don't get rid of it, then we've probably picked the wrong number. So let's say I accidentally picked 3. Well, 3 divided by 2 is definitely not 1, so let's go back to the drawing board. So this 2 over 2 cancels out and becomes a 1. So I'm just left now with an x, or a 1x, but we won't bother writing the 1. Or I can write the 1 for now. And then on the right-hand side, we have 2 times 3, which gives us 6. So our final answer is x is equal to 6. And we're done. I'm going to erase this and go to the next one here. Okay, so in this one, I have a -20 on the bottom underneath my x. So I can see that x is being divided by -20. So the question is, what do I do? So because it's being divided by -20, I'm going to multiply this side by -20 and this side by -20, because whatever I do to one side, I know that I have to do to the other. So I still have my x over -20, and you do not, so the question typically I get by now is, do I need to show all these steps? Absolutely not, but the more you show on an assignment or a test situation, the more part marks I can give you. But you definitely don't need to show all these steps. So these go away, which is why I did it. And I made sure that I used that negative, right? Because if I don't use that negative, then I risk being left with that negative with that x, and I really don't want that. So I'm going to just go ahead and do it all at once. So -20 times 10 gives me -200, and I'm done. So we are just going to do this second one here on the right hand side because we have space. So there's two ways to think about this, but whenever I see a fraction in front with a 1 on the top or anything on the top, I'm just going to extend this division line essentially. So, and I can do that because this x is just over a 1 anyway. So when I do that, I'm going to do 1 times x, so I'm going to have an x over 2. So 1/2 times x is the same as x over 2. So I just extend that division line. And now I have something that looks more familiar. So I can see I have a 2 on the bottom. So I'm going to have to multiply this side by 2 to get rid of the 2. And whatever I do to one side, I have to do to the other. So this 2 goes away. I'm left with just an x, and I get 2 times -5 gives me -10. So my answer is x equals -10. Okay, so now we have pesky fractions. Every student who maybe math isn't your favorite subject, fractions seem to be like a huge problem area. So we always like to include fractions in our lessons just to make sure. Now, remember, we have that handy dandy fraction button on our calculators. It might not look like this on yours, but that's what my fraction button looks like on mine. So when we do this, remember what we learned in the my calculator's not here, but what we learned in the last few lectures was that we can actually use that fraction button, and it's going to save us like a ton of time. So let's figure this out. So in this one, I can see that x is being divided by something, and it's being divided by a fraction, and that's okay, but we're just going to think of it as a number. So if this was a -2 and it was being divided by -2, we'd multiply by -2. But because it's being divided by a fraction, we just have to make sure we keep the entire fraction. So x is being divided by -2. So to get rid of it, we're going to multiply, or sorry, not -2, -1/2. We're going to multiply by -1/2 on both sides. So we look at what's happening, we're going to do the opposite. So I have -1/2 on this side. It's going to look a little messy, but that's okay. And I'm also going to multiply by -1/2 on the right side. These cancel, which is why I did it. So now I'm just left with an x. And now I have -1/2 times 4. And you can use the fraction button or you can just do this in your head. So we're cutting that 4 in half. So we get -2 as our final answer. So x is equal to -2. So we're treating it the exact same as if it were a like a non-fraction, so just a whole number. So now on the second one, my x is on the right hand side, but that's okay. And I can see that x is being divided by 5/6. So that means I'm going to multiply by 5/6 on both sides. So we're going to multiply this side by 5/6 and this side by 5/6. That gets rid of this fraction. And then if you don't have the fraction if you don't have the fraction button, you can go 5 times 12 in your calculator and then divide by 6. And that will give you a 10 is equal to x. Or you can use the fraction button, 5/6 times 12. And your answer is 10. So it's not any harder in terms of the actual algebra that goes into it, but because it's a fraction, it seems to sort of freak students out. So I hope that helps clarify that. Okay, now we're going to talk about squares and square roots. So we've learned to solve an equation by undoing an operation. So you have the inverse operation and we do it to both sides of the equal sign. So for addition, the opposite is subtraction, and for multiplication, the opposite is division. And in the same way, when we have something being squared, the square root is an opposite operation. So